Today we're talking about piecewise functions. What are piecewise functions? Well, it's going to be at least two equations kind of on a graph where each of those equations, whether it's two or more, are going to be applied to a different part, or you might say a different piece of your domain. All right, so from left to right, if you think domain is your x values, maybe one piece is one equation, another piece is a different equation. There could be multiple of those. So let's take a look at what I mean by that. All right, so here we have our normal g of x, but then our function is split into these two different equations. And you'll notice that it's restricted when the domain is either less than 2, or for this bottom one in purple, when x is greater than or equal to 2. So you might want to, at 2 on your x-axis, put just maybe a little dotted line here, because we're going to be less than that for the top one and greater than or equal to that on the bottom one. All right, so our goal is to graph this thing, and the top part says g of x equals negative 1/2 x minus 1. This is just written in the form y equals mx plus b, okay, where we normally start at our y-intercept, which is negative 1 here. So I'd put a dot there at negative 1, and then it's asking us to go down 1 and to the right 2. So down 1 to the right 2. However, if I do that, I can't really go any further than that, because here my domain is restricted for when x is less than 2. So instead of going down and to the right, you might want to go back to your original point and go up 1 and left 2. Do that a few times, up 1, left 2, okay, until you get a nice line going, which you can connect those dots, okay, just like this. However, since this is just x is less than 2, remember back to algebra 1, where this would be an open dot there? You're going to also put an open dot here because it's not including the 2. The 2 is going to be included in our next one. So maybe go ahead and draw an arrow on the end of that line. It's looking like this. On our next one, it says g of x is equal to 3x minus 7. So let me switch colors here in purple. I'm going to start down at negative 7. So 1, 2, 3, 4, 5, 6, 7, right there. But I can't be over here yet. So you might want to do this in pencil or something, because we're going to start on the other side of that line. This says 3x. So at negative 7, you would go up 3, 1, 2, 3, and over 1. And then do it again, up 1, 2, 3, over 1. Now here is where I can make a closed dot, right? Because it's greater than or equal to the 2. And then from that dot, I would do it again, up 1, 2, 3, and over 1, up 1, 2, 3, and over 1. And then here you can connect those, draw an arrow. And so this is a function because from left to right, every part of our domain is covered, right, including 2. It's not on the black one because this is an open dot, but at the purple one, it is closed. So that gap is actually taken care of from left to right in our domain. Let's try another one. Another piecewise function here. This time it says h of x equals these 3 different pieces of our domain, all right, denoted by these inequalities over here. And the first piece says h of x equals negative 4x. Now, if we want to think of this in terms of y equals mx plus b, like a line, the b would be plus 0, right? Y equals mx plus 0, because we're not starting anywhere except for the origin. So here at the origin, I would have to go down 4 and to the right 1. However, this is restricted when x is less than negative 2. So instead of going down 4 and to the right 1, I might actually go up 4, 1, 2, 3, 4, and to the left 1. And if I do it again, up 1, 2, 3, 4, to left 1. Now finally, I am past negative 2, okay? And it's going to actually be an open circle right there. And then if I go up 1, 2, 3, 4 again and to the right 1, I would have a line that looks like this. So it's an open circle right there because that's where negative 2 is on our domain, on our x-axis. All right, and then the next one in purple, this one is asking us to say h of x is equal to x plus 1. So if I start at the 1 itself, right here, then I would just have to go up 1 and over 1. My slope is 1 over 1, right? So if I go up 1 and over 1, I can do that again, up 1 over 1. However, you got to be careful here, because if I go down 1, left 1, this domain is restricted between negative 2 and 1, right? So at negative 2, start there, it's going to be a closed dot because it's less than or equal to. And then it's also x is less than 1, so I would not use that last point that I did. And at there, it's going to be an open dot. Okay, so it's going to be this little line segment. Let's try to make it straight with a closed dot on the left side at negative 2 and an open dot at 1. right? The last part of this in black says the square root of x. And remember, the square root, you might want to think numbers that you can take the square root of nicely. And there, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is the next nicest one. So if I go over to, let's see, 1, 2, 3, 4. Square root of 4 is 2. And then the last, oops, where it's supposed to be, the last nice square root that fits onto our graph is going to be the square root of 9, which is 3. 1, 2, 3. So I have this point right there, which is 9, 3. Right? Now, how am I going to graph this? Well, I can only start at 1. So I would not have a dot there at 0, 0, but I'd have a closed dot at 1, and then it's going to be kind of curved up that way going to the right. All right, it's the square root function. If that was on a smaller graph, it'd probably look more curved than it actually is. All right, so this is the pieces of that graph. Now, on the red one and the black one, those do go forever in each direction, left and right respectively. So keep that into consideration as well. Our last piecewise function that we're going to do says f of x equals these three pieces, all right, restricted by those domains. And so the first one I'm going to do in red says f of x equals 2x plus 1, again written in that form, y equals mx plus b. Okay, so here, if I think about that, the b is going to be 1. And so I'd put just maybe a little tiny dot right there at 1, tiny dot, or maybe in pencil if you're doing it, because we won't really start this until we get less than -4. And so if you think about what's happening here, it's asking us to go up 2 and to the right 1. If we think of this as the slope of 2 over 1, it's usually up and to the right. However, for me, because I don't want to go that way, I want to be less than -4, I'm not going to go up 2 and to the right 1. I'm going to go down 2 and to the left 1. Again, put a little tiny dot there. And then do another left 2, or down 2, left 1, another down 2, left 1, another down 2 and left 1. Okay, so I think we get to -7 on the y-axis, which is finally at my 4 on the x. So this is the point -4, -7. All right, and at that point, I can finally draw an open circle, right? And then again, go down 2, left 1, oops, left 1, down 2, left 1, and this part of the graph would be going just down that way. All right, that's probably not the best line. It probably should be a little bit more down, but you get the idea. You probably have graph paper that you can use. Now, all these other dots I can erase because I don't need that. I just want this one is less than the -4. And again, less than is why it has the open dot. All right, let me switch colors to be the purple one. This time it says it's just going to be f of x equals 4. How do you do that? Well, remember, f of x means y. So this is really just saying the line y equals 4 between -4 and 0. All right, well, the line y equals 4 is a horizontal line up here at 1, 2, 3, 4. Okay, and so at -4, 2, 3, 4, it's going to be a closed dot. And at 0, it's going to be an open dot. And you're just going to connect those two. Again, this would be the horizontal line y equals 4, but it's restricted between those two different parts of our domain, -4 and 0. All right, the last part in black is going to be x squared. Now, if you think about the function y equals x squared, this is a parabola. And since we're restricted for just the right side, or when x is greater than or equals 0, it's going to be just the right side of our parabola. And so you can plug in the numbers if you want. 0 squared, which is included, so it's going to be a closed dot, is 0. 1 squared is 1. 2 squared is 4. 3 squared is up here at 9. And then after that, I think I'd be off my graph. And so it's going to look like that curve of a parabola over here on the right side of my graph like this. Okay, so again, this would keep going on forever to the left, to -infinity. That would keep going over to the right, to positive infinity. And so all parts of our domain are covered. So this function does work. And that is how you graph piecewise functions.